All right, here we are at question number 3. We want to pick all of these fractions that are greater than 75%. So the big idea is, how can we change a fraction to a decimal or to a percent? And another strategy to think in mind here is benchmark fractions also draw a picture. What I mean by a benchmark fraction, a lot of you know that 1/2, for example, is 50%. So that's kind of like a benchmark. It's one of those ones we can measure, is it more than 1/2 or less than 1/2? Another benchmark that comes up an awful lot is 3/4. So 3/4 is actually equal to 75%. If we just know that, and if we just have that memorized, then we could actually go to drawing a picture. So 75%, we would cut it in half, cut it in fourths. Here's a model that represents 3/4, which is 75%. Okay, so for example, the 1/2 we know is 50%, which we could tell already is less than 75%. But if we were to do a model, cut it in half, there's the model for 1/2. We could see that 1/2 is not greater than 75%. All right, but what about these other ones? Let's take a look at these other models. Okay, so 5/9 and 8/9. Well, how do you draw ninths if we had to do the drawing a picture? All right, so one way to draw ninths is we're going to try to cut this in thirds. Kind of looks like a peace sign there to make it in thirds. Now, to make your thirds into ninths, take each of these thirds, there's 1/3, 2/3, 3/3, and cut them into 3 slices. So 1, 2, 3. We'll do the same for this one. 1, 2, 3, and the same for this one. 1, 2, 3. When you draw these models, you try to get the pieces to be as close to equal sizes as possible. So I did a pretty good job there. Okay, so let's do that for 5/9 as well. So this will represent 5/9. We'll start with thirds, and we'll take each of these thirds and slice them into 3 little pieces. Okay, so 5/9. 1, 2, 3, 4, 5. So based on the diagram, 5/9 looks to be not bigger than 75%, which is 3/4. Also, 5 is just a little bit more than half of 9. So this is significantly more than half. This is just a little bit more than half. So not bigger. What about 8/9? So there's 1/9, 2/9, 3/9, 4, 5, 6, 7, 8. 8/9 is almost the whole pizza. So it does look to be greater than 75%. Okay, what about 4/5? Okay, so how do you take this pizza and cut it into 5 equal slices? For fifths, to me it kind of looks like somebody doing a jumping jack. This is their head right there, that's their arm going out, their other arm going out, and their leg. So I think of somebody doing a jumping jack to try to cut it in fifths. And you want each of these slices to be as close to equally sized as possible. If you mess up and you're like, man, that one's a little too big, you could always just start over again, because it is a little bit tricky to draw some of these models. All right, so let's do 4/5. 1, 2, 3, 4. And what do you think? That's pretty close to 75%. Does it look like it's more than 75% to you, or less than 75%? Okay, so to me it looks like it's greater than 75%. So I would say that 4/5 and 8/9 are our answers. But let's say we're not sure about this one, because it does look pretty close. Let's talk about how can we change a fraction to either a decimal or a percent. Okay, so percent means out of 100. So, and this one is pretty nice because we could change 5 to 100 pretty nicely. This might remind you of ratios like we had in the first question. So a lot of times in math, once you learn one skill, you'll see that it's applied in lots of different scenarios. So this 4-to-5 ratio, or 4/5 fraction, can be changed into something out of 100. We're scaling it up. So the question is, what number do we multiply by 5 to change it to 100? And if you figure that 5 times 20 is 100, you could do 4 times 20 to figure out how much would it be out of 100. 4 times 20 is 80. So if it's 80 out of 100, that means it's 80%, because percent means out of 100. So that proves that 80% is more than 75%, So we were right in assuming this one was bigger than 3/4. Something else I'd like you to know is that every fraction is actually a division problem. Every fraction has a numerator over a denominator, and it equals the numerator divided by the denominator like this. Notice the numerator goes on the inside. So in this specific question, this is actually 4 divided by 5. 4 on the inside divided by 5. Alright, so 5 does not divide into 4, because notice it's not equal to one whole pizza, so it's 0. But we can add a decimal after the 4 and make it 4.0, as long as we move this decimal straight up. Okay, so now we're going to continue to do this division problem. What is 5 divided into 40? It's 8. 8 times 5 is 40. So it turns out that 4/5 is equal to 0.8. We did a division problem to make it into a decimal. So it's 0.8. Now, if you want to make a decimal into a percent, all you have to do is move the decimal twice. This will work for any decimal. Just go 1, 2. What do you do with this blank spot, though? Well, that blank spot is going to be your 0, and that's how you get 80%. So we got 80% by making it out of 100, but we could also get 80% by doing the division problem. Every fraction is a division problem, and moving the decimal to the right 2 times. And again, 80% is bigger than 75%, proving that 4/5 is greater than 75%. Okay, so there's a lot to kind of understand here about converting fractions, decimals, percents, but I want you to make sure that we know we could draw a picture whenever we get confused to kind of help us understand a little bit more. And these benchmark fractions, as far as like 1/2 is 50%, or 1/4 is 25%, 2/4 is 50%, 3/4 75%. Some of those benchmarks are really huge to have memorized, and if you have them memorized, it can make a lot of math way easier. We're going to come back to some of these ideas a little bit later.